in this example, we are given the n term of a series to be this expression. We have to find the sum of the first n terms. So at first glance at it, we can't identify what type of series it is. Is it a geometric series or is it an arithmetic series? We don't know. So let's write it out using the summation sign. So the sum of the first n terms is given by summing from n equals to 1 to capital N of this whole expression. Okay, so you see that we can split it up into sum of 2 to the power n minus 1 and sum of 5n plus 2. Firstly, let's look at this part. When you can't see clearly, like whether it's belongs to an arithmetic series or a geometric series, okay, it'll be useful to write down the first few terms. So if we expand this out, it will be 2 to the power 0 plus 2 to the power 1 plus all the way, okay, one more term for you, 2 to the power 2 plus all the way up to 2 to the power capital N minus 1. So you observe that this is clearly a GP. Okay, the terms clearly belong to a GP. First term is 1, which is equal to 2 to the power 0. And the common ratio is 2. How many terms are there? The number of terms will be the top minus away the bottom plus 1. So the number of terms is n minus 1 plus 1, which is n terms. Okay. Now we look at this part, shaded in yellow. Okay, again, if you can't see directly, it will be helpful to expand out the terms. So the first term is 5 times 1 plus 2, which is 7. The second term is 12. The next term is plus 17, so and so forth, until the last term is 5n plus 2. Taking a closer look is an arithmetic progression. So the first term is 7, the common difference is 5. So how many terms are there? Again, there are n terms altogether, capital N terms. So applying our formula for the sums of AP and for GP, okay, the GP works for the first part, this one. So recall the formula. What is the formula for GP? It is Sn equals to A bracket R n minus 1 over R minus 1. Now, the sum of an AP will be Sn given by n over 2, 2a plus n minus 1d. So applying that, we'll be able to obtain our answer.